Hello students, today we are going to study about the concepts of the reaction mechanism. We'll be seeing how it takes place, okay, and we'll be understanding that. So, in order to study or know the concept of reaction mechanism, we will be seeing different stages, okay, which are there in that. Okay, first is the bond cleavage, okay, and then we'll be studying about attacking reagent, reaction intermediate, and then the electronic effect. Okay, so first with the bond cleavage. When I say the word cleavage, what do you understand? It means breaking off. Okay, when I say fission, it is also breaking up. When I say cleavage, it is also breaking up. Okay, so this bond cleavage is of two types. Okay, one can be heterolytical cleavage or fission, you can say, okay, and the second is the homolytical cleavage or the fission. Okay, when I say hetero, you all know, means different, not same, isn't it? So, in case of heterolytical cleavage, we'll be seeing when the bond breaks, one of it will consist of more electrons, other will consist of less, or the number of distribution of electrons will be different. Okay, and this type of cleavage is known as ionic cleavage. Now let us see it. Okay, suppose one example I have taken. Here you can see these two elements C and Z. C, obviously it is for carbon. Okay, now here you can see one of the electron of carbon and one of the electron of what the other element. If it has formed a bond, now it is breaking. You will be seeing what? This electron of carbon is also being taken up by the other element. And this element is consisting of now two electrons. As a result, it becomes a carbocation and the other one becomes a negative sign. So in this type of cleavage, there is not equal distribution of electrons, and as the result it is known as heterolytical cleavage. Same thing here, if the carbon takes the electron of this element also and it becomes a positive cation and this becomes a carbanion, okay, here also unequal distribution of electrons. Naturally heterolytical cleavage. Okay, so this type of cleavage where unequal distribution of electrons takes place during the cleavage is known as heterolytical cleavage or heterolytic cleavage. Okay, and this is known as what? The ionic cleavage. Why? Because the electrons are shifted towards one side only. It is not being shared. Okay, so it is a ionic cleavage. Now, if about homolytical cleavage or fission. Homo means what? Same. So here when the cleavage takes place, what happens? Both of it will consist of equal number of electrons after cleavage also. Like here carbon is consisting of one electron, another Z is also consisting of one electron after the cleavage, and so it is known as what? Homolytic cleavage. So moving forward with the next step, that is the attacking reagent of the reaction mechanism. Okay, after the fission has been done, after the cleavage has been done, naturally what will be acting on that cleaved portion? Okay, that is the attacking reagent, isn't it? Because now either they are having positively or they are negatively charged. In case of heterolytic, in homolytic also you will be seeing it will be consisting of one electron, okay, which needs to be balanced. Okay, so what will be the next step will be the what? Attacking reagent. So these attacking reagents are of two types. Okay, electrophilic reagent, or we can simply say it as electrophile. Okay, and nucleophilic reagent, or we can simply say nucleophile. When I am saying electrophilic reagent, okay, or a electrophile, the word just simplify that word. Electro and philic. Electro means electron, philic means loving. It means it is electron loving, so it will try to take the electrons. Okay, and so they are what? If they are electron loving, naturally they will be positively charged because they will want the electron to come towards itself. Okay, so the examples of this are if we say about positively charged, we can say H plus ions. And yes, some electrophilic are also Lewis acids which are neutral in nature, like BF3, okay, and so on. Now, nucleophilic reagent or a nucleophile. When I say, again simplify the word nucleo plus philic, what will happen? It is nucleo means nucleus, philic means loving, okay. So it is what? Nucleus loving. It means it will try to take the electrons, isn't it? So here, which will try to have positive charge, that is the negative charge particles like H minus ions, okay, or we can say simply Lewis base like H2O, because O consists of lone pair of electrons, okay. Now, what is ambient nucleophile? Actually, ambient nucleophile, either of them can try to take up the reaction, because it will be having the same charge. Like if we are saying NaCa triple bond end, okay. So sodium, carbon and nitrogen are here. Cn is bonded by triple bond. Naturally, what happens here? Carbon, what happens? It gets one electron. As a result, it becomes negatively charged. Nitrogen is also negatively charged. Naturally, the transfer, or it can react in any of the way, in any other of the sides, like from the carbon side also, or from the nitrogen side also, to take up the positive charge, okay. So after attacking reagent comes the reaction intermediate, okay. So what is this reaction intermediate? You can see here formation of carbocations or carboanions, or there is a free radical, or there are carbenes, okay. These have been formed, okay. And here what will happen? These all will be reacting with certain things, because this is a reaction intermediates, okay. So here what happens, like if a carbocation is formed, okay, so naturally what will happen? Some nucleophile will try to get and attach towards it, okay. Suppose any nucleophile you can take like OH, okay, it will try to get attached with what? This carbon, okay. Likewise, if I take carboanions, okay, negatively charged carbon atoms, okay, have been formed. Here any electrophile can attach to it, like anything you can take, H plus ions also you can take, it can come and attach over here, isn't it? Now, free radical. When I am saying free radical, okay, here naturally if any cleavage has been done, okay, like homolytic cleavage only we can see, like Cl2, okay. So Cl and Cl, okay, what happens? In this homolytic cleavage takes place, and one Cl consists of one electron, another the another one, and now naturally it can come and combine and make it stable, okay. Like that, carbamines, okay, carbenes, what happens here? We are seeing one pair of electrons are totally free over here, and so it can, okay, attach with any other, as it is having excess of electrons, it can attach with the electrophiles very easily, isn't it? So these are the reaction intermediates. So students, we have studied about the reaction mechanisms. It's 3 steps, okay. The first was what? The bond cleavage. Second was the attacking reagent. Third was reaction intermediate, and the fourth step was the electronic effect. This electronic effect, actually it consists of inductive effect, mesomeric effect, and then electromeric effect and hyperconjugation. Okay, so these 4 we will be studying in the next video. This 4th step of reaction mechanism we will be studying in the next video. Okay, so good day, take care.